In our next problem, I want you to find the exact value of x. Notice I know the hypotenuse is x, or my leg, times the square root of 2. So I know x times the square root of 2 equals 18. Now let's review what do you have to do to get x by itself. And what do you do when you have a square root in the denominator? So I get x is 18 divided by the square root of 2. You cannot have square root in the denominator from algebra. So whatever is in the denominator, we multiply the numerator and the denominator by the square root of 2. So my numerator becomes 18 square roots of 2. My denominator, I'm taking the square root of 2 times the square root of 2. If you think that's the square root of 4, and the square root of 4 is just plain old 2. That's what we call it rationalizing the denominator, because now I've got a rational number in my denominator. And I still want to simplify that, so I get 9 square roots of 2. So x in this problem is 9 square roots of 2. If I haven't mentioned it before, you need to memorize this. No formula sheet on your test. You got to know this rule. Now, on the next one, we're going to look at another triangle, another special right triangle. This one comes from the fact that I have an equilateral triangle. So what happens when I draw in my equilateral triangle, when I draw in my altitude, it's also an angle bisector. So that I got a 30-degree angle up here. I'm going to call my 30-degree angle, or the side opposite my 30-degree angle, x. Now notice this is a median. So my whole length is going to be 2x. Since it's an isosceles triangle, I know my hypotenuse is 2x. And then I want to find the side opposite the 60-degree angle. Well, let's call that a letter. Let's call it y. So I'm going to say c squared equals a squared plus b squared. Well, in this case, my hypotenuse is 2x, isn't it? So 2x squared equals x squared plus, I said I was going to call this y squared. Now what I want to do is I want to find an expression for y. So I'm going to minus x squared from both sides. Well, I better simplify that before I start subtracting. Okay, let's do that, because otherwise people get confused. So 2x squared is 4x squared equals x squared plus y squared. Minus x squared from both sides. You get 3x squared equals y squared. And then I'll take the square root of both sides. So y, the square root of x squared, is x times the square root of 3. So when we have a 30, 60, 90 triangle, might not have drawn this to scale. So here's my 30-degree angle. Here's my 60-degree angle. What we're going to do is we're going to call the side opposite my 30-degree angle my short leg. Everything I do is defined in terms of my short leg. My hypotenuse, that's going to be 2 times my short leg. And then over here, my 60-degree angle is my long leg. And I'm going to say that's the square root of 3 times your long leg. Oh, not your long leg, I'm sorry, times your short leg. Always find the short leg first in a 30, 60, 90. Identify that. If you don't identify it, find it. Always find the short leg first. So in this example, notice I don't know the short leg, do I? So what do? I know 12 is my long leg. I know 12 equals my short leg, in which this case we're going to call it x, times the square root of 3. So then I'm going to divide by the square root of 3. And I'll rationalize that by multiplying numerator and denominator by the square root of 3. So then we get x equals 12 square roots of 3 all over 3. Square root of 3 times square root of 3 is 3. So I get 4 square roots of 3 for x. So x is 4 times the square root of 3. And then to find the hypotenuse, y, my rule is I double the short leg. So I go 2 times my short leg. Well, now I've defined my short leg as 4 square roots of 3. I'd say 2 times 4 square roots of 3. We'll get 8 square roots of 3 for my hypotenuse. Now, do I always have to do this rationalization stuff? Well, if it's a math question, yes. But if it's a design question, then no. Let's take a look at our design question here. It says, Destiny makes and sells upcycled earrings. The earrings are made from congruent equilateral triangles. So I'm going to use my 30, 60, 90 rule here. Each triangle has a height of 2 centimeters. So I'm going to go ahead and I'm going to draw that in here. So this is 2. Whoa, I made that way too. Oh, I was using the highlighter. That's why. Or my pointer. This is 2 centimeters. And then the hook attached is 1 centimeter. So I know this is 1 centimeter. Destiny needs to mail the pair of earrings to a customer. She mails the earring in a rectangular box. What's the width and length that must be the base of the box to have so the earrings will fit if they're placed side by side in the box, in the bottom of the box? So in other words, I'm going to put them in here like this. Now, let's draw this out. So what happens here, my height is 2. That is across my 60-degree angle. I want to find my short leg. So I know my long leg, which is 2, equals my short leg, which I don't know, call that x, times the square root of 3. So I'll divide by the square root of 3. So I'll take 2. Since it's an application problem, we'll take 2 divided by, whoops, forgot my division sign, divided by the square root of 3. And I'll get like 1.15. Now, if my earrings fit snugly in there, that is exactly. Well, I know what happens is my height of my box is going to be 2 plus 2 plus 1. So I know it would be the box has to have a width of 5 centimeters. Now remember, I only found half of this. So this is 1.15. So that makes my whole length here 2.3. And if they fit exactly side by side with nothing in between them, I would have 2 widths, don't I? So I'll take 2 times 2.3, and I'll get 4.6 centimeters. So to get my earrings to fit exactly, I would need a box that's at least 4.6 by 5 centimeters. Maybe a little bit more than that because you want them to fit, but I don't want to bounce it around. So if you fit them in exactly tight and they don't break, it would be 4.6 by 5 centimeters for the length and width of my box to get my 2 earrings to fit in there.